Alright guys, welcome back to another video, and today we'll be talking about how to actually solve functions and how to basically get it from a function notation to an answer. But before that, we're going to go through a few important vocabulary. So first you need to know what the difference between a domain and a range are, right? A domain are basically the the x values, right? Wherever your graph, whether it's a nonlinear function or a linear function, whether it's a line, a quadratic, anything like that, wherever it intersects the x-axis, at what point, whatever intersects y-x-axis, that point is known as a domain, one of the domains, right? Because there could be multiple domains. But for a line, obviously, there's only going to be one domain, or zero, or maybe infinity, right? If it's like a line that's let's say y is equal to 0, right? But yeah, so that's basically what a domain is, right? A domain is a set of x values. So there's another thing about domain is that it can either be expressed as areas where the x values on the graph intersect the x-axis, or it can just be the set of x values, right? Every set, the x value should have a corresponding y value, otherwise it's not an x value for the graph. Another thing that I was explaining earlier, where it intersects the x-axis, that's also known as an X-intercept, where it intersects or intercepts the line. So just something you can learn about. Alright, so the next one is range, right? Range. The range is a set of y values. It's a set of y values. This is just like the domain, except it's for the y values, right? For every y value, there should be a corresponding x value. If there isn't, then that's not a y value, that's part of the graph. So now let's go to function notation. What exactly is function notation, right? Function notation. Function notation is basically a form that you put any type of function or equation in, and basically transform it into making it into this type of notation. So for example, right, let's say we have the equation y equals 3x plus 5, right? How would you make this into a function, right? How would you make this into function notation? Well, it's actually really simple. All you have to really do is just change the y into an f of x, right? Everything else is the same. So just the f of x is equal to 3x plus 5. And the reason for this is basically you're just saying the function of x is equal to 3x plus 5, right? So that's basically it, guys. That's all you have to do to change it from normal notation to function notation. Just change the y into f of x. No matter if it's in this one, right? Say it's 3x plus y equals 6, right? Then all you have to do is just, like I said in the earlier videos, always try to put into y equals mx plus b format, which would be in this case y equals negative 3x plus 6, because all you're doing when trying to put it in y equals mx plus b format is isolate the y. So from here you have y equals negative 3x plus 6, and this will become f of x is equal to negative 3x plus 6. So yeah, guys, that's basically a summary of function notation. So what is a relation now? Let's just go through what a relation is and the difference between a relation and the function itself. So a relation is basically a set of numbers where in one set, right, which is the x values, which is what, guys? The domain, right? When you have the domains and then the y values, which is the range, right? That's just any set of x and y values. It doesn't matter what they are, right? For any x value, you can have a corresponding y value, right? Anything. That's what a relation is. But a function is something more specific, right? But a function is basically when for every x value you can have several y values, but for every y value there can only be one x value, right? There can be two x values going to one y value. Otherwise, you don't know which one to go to, right? So yeah, that's basically it for a function. So just a quick definition for what a function is, it's basically like a special type of relation, like I was saying earlier, in which each value of the domain, in each, let me just enter, in which each value of domain corresponds with exactly one y value, right? I think I might have said there should only, I think I might have said that there should only be, for every y value there should be 2 x values. It's actually for every x value there should only be 1 y value, right? For every corresponding x there can only be 1 corresponding y, right? But for every corresponding x you can have several, for every corresponding y you can have several x's, right? You can have several domains, but you can't have several ranges for just one domain, because you don't know what, like for x, right? How do you know if x should go to 3, or if the positive 3, or if x should go to the negative 3 for the y value, right? So that's like a certain thing. It's kind of like a restriction to keep in mind for what makes a function. And another thing, guys, is that in order for you to test a function, right? In order to test if like a graph is a function and it can't like figure it out just by the function itself, always something you can do is just the vertical line test, right? The vertical line test, right? Let me just get rid of all of this. The vertical line test, which is, just abbreviate it, is basically where you can put a line through any part, like any part of the graph, a vertical line through any part of the graph, and if it touches your graph more than once in any part, you have to check every single part, right? If it touches a graph in any part twice or more, that means that it's not a function, right? Because that means that for every x value there is more than one y value. So that's just something to keep in mind. So yeah, that's basically it, guys. And now let's go into function notation, because we just completed our vocabulary, so you guys should get a pretty good understanding. Let's get rid of this. Alright, so for our first question, right, we have find f of 2. Find f of, so here, find f of negative 2 for the function negative x squared minus 2x plus 4, right? Let's move this over here so you guys can see it. There you go. Alright, so from here, right, it's basically just like how we did in solving expressions in Unit 1, I think. But the difference is that you have it in a different format, so it's a little harder to understand, right? You see like an f of negative 2 and you don't know what to do with it. Here, let me just add this, guys, so you know what I'm talking about. F of x. F of x, right, equals. So here, right, you see that it's in its format, right? You see that it's in the f of x equals a function format. And if you guys could really see it, you might have seen that this is actually a quadratic function, because it has the x squared and then the x and then the constant. But anyways, that doesn't matter right now. What we're trying to do is we're trying to make it so that we can solve this function. And something we can do is, right, if it says f of x in the beginning before the graph, like f of x equals, in this case, negative x squared minus 2x plus 4, you know that the f of negative 2, the negative 2 replaces the x in the equation, because that's basically like substituting. So for every part that you see an x inside your equation, or your function, should I say, then you just basically substitute it with negative 2, or whatever constant is inside that part. So in this case, we'd have f of negative 2. You don't really need to put the negative 2 in that part, but it's just easier for you guys to understand that you can do it in every single spot. And then f of negative 2 minus negative 2 squared minus 2x, or should I say minus negative 2 plus 4. From here, just solve. It's pretty simple. I've done this quite a bunch of times, but I'm just going to go through it. F of negative 2 equals negative 2 squared is what? 4, right? And then you have that negative on the left side of it, so it would be negative 4. And then negative 2 times negative 2 is positive 4, so plus 4, and then plus 4. So from here, you finally end up with f of negative 2 is equal to f of, negative 4 plus 4 is 0, 0 plus 4 is 4. So f of negative 2 is 4. So this is like an easy way to understand it. It's basically kind of like dissecting the function and like substituting your values and finding the constant value. So that's the way you know that for f of negative 2 equals 4, right? And something really cool about this is that if you graph this in your calculator, right? If you graph this function up here, negative x squared minus 2x plus 4, and then you see this, right? Our answer, f of negative 2 equals 4, that our answer is actually a coordinate, right? Because you see that f of, like for x, which is negative 2, you get a y value of just 4. So negative 2 comma 4 should be a coordinate on your graph. So that's something really cool. Like, if you wanted to find, like, anything, like, if you had, like, a certain x value, right? And you wanted to find out its corresponding y values, that's how you, literally why you're solving the function, to find that value. So anyways, let's go to another example, right? This one's a little different. So let's see. We have determined the range given domain. Just set this up here. Okay. So from here, and our domain is, well, so we have our graph, right? Our function is f of x is equal to 3x plus 4. And then our domain, is negative 2, 0, and 5, right? So those are our 3 points, right? Our domain is negative. We have negative 2, 0, and 5. So basically our domain, like I said earlier in the video, is it's basically a set of x values, right? Oops. Why do I have an apostrophe here? It's basically our set of x values. And our range is our set of y values that corresponds to our domain, right? So like I said in this first question, if you want to find the value for the right side, and then this is our equation. I think this is kind of confusing. So this is our equation for you guys. So anyways, right? That's our domain. Negative 2, 0, and 5. So in order to find a range, like I said earlier, you need to input your values in the domain and put it into the equation to find your values for the range. So like how we always been doing, right? So let's start with negative 2, right? So f of negative 2. So you have f of negative 2, right? It's equals f of negative 2 equals 3 times negative 2 plus 4. Okay? And then from here, you would have f of negative 2 is equal to 3 times negative 2 is negative 6 plus 4, which is equal to negative 2. So you know that f of negative 2 is equal to negative 2. So when the domain is negative 2, you know the y value or the range for this given equation is negative 2. Let's go to another example, right? Let's look at let's go to our second set, right, which is 0. So now we have f of 0 is equal to 3 times 0 plus 4, which is equal to 3 times 0, 0, 0 plus 4 is 4. And so something you guys should pay attention to is that whenever you're solving these equations, right, and you have a 0 in one of your coordinate parts, like if you have a 0 in your domain, or you have a 0 in your range, that's actually a very important piece of information, right? Because those are known as the X-intercepts and Y-intercepts, right? Like I explained earlier. The X-intercepts, right, those are basically when x is equal to 0, when y is equal to 0, right, and your x is a certain number. That's basically very important for, like, later you'll see that's actually very important when trying to graph functions and do anything you want with functions, right? So, like, and then same thing for y-intercept, right? That's when x is equal to 0 and y is, like, going up or down the y-axis. So those are some key things to look out for whenever you're solving or given different types of tables for coordinates. But for now, we're just going to stick with these questions. So f of 5 is equal to 3 times 5, 3 times 5 plus 4. 3 times 5 is 15, 15 plus 4 is 19. Oops. Equals 19. So you know that f of 5 is 19, f of 0 is 4, and f of negative 2 is negative 2. So yeah, that's pretty basically it, guys. So next, we're going to go to, like, relation types. So, like, you can have two different, well, for our cases, right, you can have 3 different types of sets, like relation types. Now you can have a relation where you have a domain, like different domain and range values in, like, coordinate forms, and you have to see if it's a function or not a function. And then you can have it in, like, table, like where you have a table with your x values on the left and then the y values on the right, and see if that's a function. And lastly, you can do this mapping, right, where you have, like, this big circle, kind of looks like a Venn diagram but not connected, and then you basically have to map, right, match the numbers with its corresponding y values, and basically check if it's not a function, right? And you're wondering, how would we do this without graphing it, right? You only told us that we can only find if the function is a graph by doing a vertical line test, right? Actually, that's not true, right? Whenever you're doing with any different types of relation types, graphing, sets, tables, or mapping, for any of these, all you'd have to do, right, like I said earlier, what are the qualifications for being a function, right? For every x value, there can only be one y value, right? So just check that, right? Let's see if we have the domain value 2, right, and put it into the equation, see if it's a different number. And if you have 2 different numbers that equal to 2, then you know, right, that's not a function. That equation is not a function, and it's just known as a relation. So yeah, guys, that's basically it. And so for the next lesson, which is lesson 3, we'll just be going over sequences, which is the 2 main sequences I will be looking at are arithmetic sequences and geometric sequences. And we'll just be going and exploring of what are those sequences, how do you determine which ones is which, and also, like, how to solve these sequences, right? How to figure out, like, the equation for the sequence by, like, get a certain number. So that'll be very interesting, so stay tuned to that. And as of now, thank you guys for watching, and I'll see you in lesson 3.